Hi everyone. Welcome to the flipped lesson on graphing linear inequalities with me, Mr. Whitehorse. As you watch this video, I encourage you to pause it and rewind it as many times as you need to in order to learn the content. I also encourage you to take notes as you watch. What I'm going to show you today is how to graph an inequality on a coordinate plane. But before we do that, what I want to review with you is how to graph a line that is in slope-intercept form. You might recall that when a line is in slope-intercept form, it looks like y equals mx plus b, where m represents the slope and b represents the y-intercept. You can see in this example, the y-intercept is -2, and the slope is up 3, right 4. Therefore, the equation that we use to graph that line is y equals 3 over 4x minus 2. So to flip that, if I were given that equation, I could graph -2 on the y-axis and then follow the slope, which is to go up 3 and right 4. So here's how that ties into inequalities. To graph a linear inequality, just like a line, there's only a couple small differences. You're going to follow these steps every single time. First, you change the inequalities into slope-intercept form. So you make them look like the equation I just showed you. Then you plot the points needed to draw the line. This is where it becomes different. Instead of just connecting the points, you have to consider which inequality symbol is being used. The first thing to consider is that if it's less than or greater than, you're going to use a dotted line to connect the points instead of a solid line. Whereas if you see less than or equal to or greater than or equal to, use a solid line. After doing that, you're going to shade the region of the graph that includes the solutions. One thing that you'll notice when we're dealing with graphing linear inequalities is that there is an infinite number of solutions for every single inequality. You are responsible for knowing which side of the graph you have to shade that has all of those solutions. And you'll see that on the next page. And lastly, you check your answer. But if you do steps 3 and 4 correctly, checking your answer is actually already done. So on the next page, I'm going to show you how this works. In this example, I am graphing x minus 3y is less than 6. And what I want you to do is just pretend that that less than symbol is an equal sign. What I need to do first is get it into slope-intercept form. That means I need to get y in terms of everything else. To do that, I rewrite the inequality. X minus 3y is less than 6. And to solve for y, I'm going to first subtract x from both sides. And my inequality can be rewritten as -3y is less than -1x plus 6. But I'm not done yet. What I now need to do is divide both sides by -3. But there's something else to consider there. Remember that when you divide both sides of an inequality by a negative number, you flip the sign. So this inequality in slope-intercept form becomes y is greater than 1/3 x, because -1 divided by -3 can't be written as a whole number, so we leave it as 1/3, and 6 divided by -3 is -2. So in that inequality, I have my slope and I have my y-intercept. My y-intercept, after I label my axes, my y-intercept is -2. And my slope is 1/3, which means I go from that starting point, I go up 1 and right 3. Up 1 and right 3. But to fill up the graph, I could go the opposite way. Instead of going up and to the right, I can go down 1 and left 3. And I'll do that one more time. So those are the points that I need. Now this is what makes an inequality different. When you're graphing a line, you would normally just connect the points, draw arrows, and you'd be done. But with an inequality, you are expressing all of the ordered pairs that will make that statement true. So you look at the symbol. You look at the inequality symbol first. Since it's greater than, that means that the points that are actually on that line are not included in the solution set. So I use a dotted line to connect the points, which I'll show you here. Instead of using a solid line, you use a dotted line when it's greater than or if it's less than. As usual, make sure you have arrows on both ends, and you label the inequality with its normal inequality. X minus 3y is less than 6. So that's one thing to consider. The next thing is where to shade. That means which side of the graph includes all of the x and y values that will make that statement true. I'm trying to find which side of the graph can I take any ordered pair to make my inequality true. Here's how you figure it out. You choose what's called a test point. And the point that's easiest to use is the origin, 0, 0. The only time you cannot use 0, 0 as a test point is if the graph itself, or the line itself, goes through 0, 0. So here I'm testing 0, 0. I'm going to take those x and y values, substitute them into the original inequality, and see if that statement's true. Let's do that first, and then I'll tell you what it means. So let's take x minus 3y is less than 6, x is 0, y is 0, and we're going to see if that's less than 6. Well, 3 times 0 is 0, and 0 minus 0 is going to be 0. So after testing 0, 0, I end up with 0 is less than 6. There are two situations that can happen. That'll either be a true statement or a false statement. Since that is a true statement, the side of the graph that contains 0, 0 is your solution set. So in my line, the side that has the 0, 0 is the top portion of the line. So what I do to represent that is I don't color it in, but I draw these lines to indicate all of the points that will make my inequality true. The other side of that line are all of the points that will not make the inequality true. And you can check your answer. If you take a point such as 3, negative 5, that x and y value pair will not make the inequality true. But any ordered pair in that shaded region will make the inequality true. So always go back to those 5 steps, pause the video as many times as you need, rewind it, make sure you understand all of it, and what I want you to do now, once you're ready, is go on the website and fill out the Google form to rate your understanding. Thank you for watching.